There are planets like birds, floating and flittering far from any star and moving through the cosmos the way a feathered animal might move across a silent lake. They taunt the stars by passing nearby them, but never anchoring themselves to any one place by way of circular orbit. These often massive worlds are solitary ice-dusted islands where there is no warmth streaming in from any sun. There is no energy for a plant's photosynthesis, and any vegetation that did exist here would soon be shriveled up and encased in glossy chambers of ice. It is a bleak place where life's emergence is neither easy nor guaranteed. What could survive on a place so frozen and so isolated? And yet it is possible that rogue planets harbor life, liquid oceans larger than ours, seeded with alien organisms in a place so remote we would think it sterile. It was a rogue planet, after all, that played a central role in the formation of our large and brilliant moon. Without this collision, it is uncertain if we'd even be here at all. There would be no moon, and no people to look up and bathe in its lunar light. Soon after the formation of the solar system, a rogue planet the size of Mars collided with the Earth. The impact released 100 million times more energy than the impact which destroyed the dinosaurs. The rogue's name was Theia. She, and the upper layers of Earth's mantle, crumbled into the surrounding space where the debris later fused together to form our moon. This is the giant impactor theory widely accepted today. But it is not enough to acknowledge that rogue worlds have already played a role in the formation of life. We must acknowledge, too, that they are possible vessels already teeming with alien organisms, crawling through the cosmos and carrying life through its shadows. Rogue planets are, as they're sometimes called, free-floating planetary mass objects, FFP, often begin with the interactions between gas giants. The balance between Saturn and Jupiter, for example, is a delicate one. If Saturn were more massive or if the two planets were closer together, their gravitational influence on one another would cause one of the planets to be ejected from our solar system. This ejection might also occur if another giant the size of Jupiter was introduced. Models of our own solar system show that the orbits of Saturn and Jupiter are likely to be stable for the years to come, but this isn't the case in every stellar system. Even planets like ours, which have remained in a predictable orbit for billions of years, could still become rogue if there was a passing star or planet which destabilized our orbit. The odds of this are low, only 1 in 15,000 according to some estimates. But what if this did occur? What if this has already happened to some distant world where plant and animal life flourished under the light of their star? Once this planet was ripped from its host star and it spiraled into interstellar space, the landscape would undergo a dramatic change. There would be no more sunny days or gold-rimmed clouds above their foliage. The lack of warmth and orbital motion would mean plants could no longer partake in photosynthesis. The temperatures would drop to -450 degrees Fahrenheit, -270 degrees Celsius. The newly exiled planet would harbor a surface now miles thick with ice. The sky, too, would change. Far from the variety of colors we witness in our own atmosphere now. When was the last time you watched the sun set or rise? When was the last time you allowed yourself to get lost in all that color? The view from a rogue planet would be dark, if star-studded. There would be no separation between day and night, winter or summer. It's easy here to lose sense of time. And yet even under those conditions there could be life. In fact, one of the places we most suspect to have alien life is a world just like this, with very little light and with a subsurface ocean possibly trapped beneath a frozen crust. It's the world of Europa, one of Jupiter's most charming moons. Europa's ocean could exist because, even though the surface temperature is about -190 degrees Fahrenheit, -123 degrees Celsius, its interior would be warm enough to host a liquid ocean due to tidal flexing. The gravitational pull between Europa and Jupiter results in heat within the moon's interior. This same mechanism could keep the oceans on moons of rogue planets liquid as well, making for an interesting home for microbial life. In such deep, dark oceans, it's fascinating to think of what kind of creatures could evolve. Huge and without eyes, or maybe quite slithery and docile. This tidal flexing would help keep the rogue planet warm as well. While most of Earth's energy comes from the sun, some of it comes from geothermal activity. Radioactive decay of elements like uranium and thorium keep the inside of our planet fiery and molten, allowing for plate tectonics. Similarly, a rogue's radioactive interior would mean a liquid ocean could persist in the absence of a star. Even if larger and more complex organisms couldn't survive the pressures and temperatures, there are extremophiles which certainly could. This geothermal activity would emit heat for billions of years, during which organisms could arise. Scientists hypothesize that rogue planets wouldn't even form a surface layer of ice in some cases. An atmosphere rich in molecular hydrogen would insulate the planet, trapping heat and adding enough pressure to keep water liquid at the surface. Estimates of rogue planets in our galaxy vary greatly. From 50 billion to 500 billion, the exact number is unknown. Because these planets are so embedded in the shadows, scientists rely on microlensing events to make their detections. Rogue planets drifting in front of a star will amplify its light for some period of time. This increase in the star's brightness will last for either a few hours or a few days, depending on the mass of the rogue planet. More massive rogues will amplify the background star's light for longer. These short-lived microlensing events are one of the only clues our telescopes receive in the search for FFPs. Like dark matter, they are largely invisible, but we are able to discern them thanks to their gravitational effects. To date, only a handful of rogue planets have been confirmed in our galaxy. There is, perhaps, something to be envied about these unbounded bodies. They follow no predictable path and face the chasm of interstellar space with just the company of their small, cratered moons. It's a much different way of life than the one we're used to. But they know their own reality, those creatures living beneath the ice on planets without a star. They know what it's like to live without seasons and suspended in a kind of timelessness we can only dream about. To be a rogue is to be uprooted and traveling about without a particular path or any particular rules. There is loneliness in that, but there is freedom in it too. Thank you for watching. Don't forget to subscribe and hit the notification bell.